So today what we're going to be going over is the third part of the quadratic formula. And now all of these are all going to have lateral roots. What that means is the fact that when we have our quadratic graphed, we're going to be graphing a quadratic that doesn't actually touch the axis. And we notice that what happens is the fact that we know that these actually don't touch the x-axis somewhere we can see. The problem is that we know the fact that with the math, we're going to get two roots. That's going to be the square root of some negative number, which means I'm going to have two answers that pop up somewhere. And what we notice is the fact that these two answers are going to be behind or in front of the x-axis. They're going to be on the lateral axis. So if we take our graph and we rotate it, and I rotate our previous graph right here, but in this case I give it a front and a back. So instead of having an xy, I have my x and my y, and I've rotated the graph out. What we know is that this graph is going to have two roots in the x-axis way back here, which in essence means that this is going to be more like a tunnel or a slide. So let's go ahead and see the true shape of a quadratic by looking at some of these lateral roots. Okay. So first off, we know that with any quadratic, using the quadratic formula, I'm going to identify my a, my b, and my c. And I'm going to take it and plug it into the quadratic equation. Negative b over 2a, which is my vertex. And I'm going to add the distance to one root, which is the square root of b squared minus 4ac. We also call that discriminant. So that's going to give me my root on the right. And then I'm going to also take it away, which is going to be my root on my left. And so let's go ahead and plug this in and see what exactly happens. Oop, tried to fill in an A there. Awesome. So here I know my B is 2. My A is 1. Oop, that's a 1. My B is 2 and 2. My A is 1 and 1. My C is 5. And let's start working this out. So I have a negative 2 plus or minus, well, that's a 4. Negative 4 times 1 is negative 4 times 5 is negative 20. 2 times 1 is 2. And so you already see a problem of brewing right here. X equals negative 2 plus or minus the square root of negative 16 all over 2. And the problem that we run into right here is if the square root of negative 16, if that were only a negative 1 and a 16, we'd be able to do it. So the square root of negative 1 is I, the square root of 16 is 4, which means this is actually 4I. So we're going to rewrite this as x equals negative 2 plus or minus our 4I all divided by 2. I know I can divide both of those by 2. It's negative 1 plus or minus 2I. There we go. We know the fact that it's going to cross the lateral axis, 1 at 2I and 1 at negative 2I. Perfect. So let's go ahead and take a look at the next one. Remember, the first thing we're always going to do is identify our A, our B, and our C. And we're going to plug it into the quadratic formula, which consists of the vertex, which is negative b over 2a. And for 1, I'm going to find the distance to the left root, which means I'm going to subtract the discriminant, which is b squared minus 4ac. And then I'm going to find the distance to the right root, which means I'm going to add that. So I get my two roots by adding and subtracting the distance to the root from the vertex. There we go. And so all we're going to do is we're going to plug in my B, which is 2, my A, which is 1, and my C, which is 17. Let's see how this works. -2 plus or minus, that's a 4. 4 times negative, or -4 times 1 is -4 times 17. Let's see, 17 times 2 is 34. It's going to be a minus 68. So again, your first clue that this is going to be lateral is you see that this is about to be a negative number, which you know means it won't actually hit the graph on the real axis. And so now we notice that in the negative 64, if I could only break that down into a -1 and a 64, I could root both of these. I know that this is an I, and I know this is an 8. So I could use 8i. Let's rewrite this instead of square root of -64 as an 8i. There we go. And again, we can reduce this by saying both of these divide by 2. Perfect. There we go. And so now, what I want you to try and do is I want you to try number 5, pause the video, resume it when you're done, and see how you did. Okay, so let's take a look. I have my A, my B, and my C. Plug it into my formula. My B is 2, my A is 2, and my C is 5. As I work this out, -2 plus or minus 4. Let's see, that's 8 times 5 is minus 40. Again, we notice that this is going to end up being negative, so I know it's going to hit laterally. Square root of -36. I know that -36, if I break that down into a -1 and a 36, I can square root both of those perfectly. I and 6, or just 6i. So we get x equals -2 plus or minus 6i all over 4. Now this I can't fully reduce, but I can divide all three numbers by 2, which says x equals -1 plus or minus 3i all over 2, which if this was a radical, we'd just be done. But again, when we have lateral numbers, we want to split it into the real and the lateral aspect. So I'm just going to break these both down into -1/2 plus 3/2 I. So that way I know I go half a unit to the left on the axis, and I go forward 3/2 on the lateral axis. And that gives me what we call, I believe, rectangular form given complex numbers. Perfect. So how are we doing? Looks like we're doing pretty good. So let's give another shot at one of those. Now that you're a little familiar with how we break it down, see if you can't break this one down a little faster. I'm going to go ahead and pop the work on here, and let's see how you did. Now, one of the things you'll notice that I do is that often I go ahead and I write out the quadratic formula, even though many of us just go ahead and say, hey, I know what my A, my B, and my C is. They just plug it in. What you'll end up doing is by writing this out, A, you commit this to memory. B, one of the big mistakes is that you saw me do it, where you'll put the wrong letter in the wrong spot. This is a very easy formula where a lot of people make very simple mistakes. So I always recommend writing it out. And the good thing about that is that when you write it out, you'll catch little things like this. Where here my B is a -4. And by writing it out, boom, boom, I see that I have a double negative, which is going to turn that positive. One of the big common mistakes we talked about previously is that that -4 somehow keeps a negative because students see -b. Well, my B is negative, so therefore that becomes -4. And that's an incorrect assumption that by writing the full thing out, you avoid it. A is 4, MIC is 5. So I'm just a big proponent of writing it out. So 4 plus or minus 16. Let's see, 4 times 5 is 20. -4 times 20 is -80, which again, we notice that it's going to hit laterally right here. -64. And so I think we're comfortable enough to notice that if I have a -64, I know that's going to give me an x equals 4 plus or minus. The real square root of 64 is 8. And because it's a negative, it's going to be 8i. So we're going to skip that middle step. If you don't feel comfortable skipping the middle step, don't worry about it. Include that. You can always write out -64, -1, 64, and then square root both of them. Get your I8, which is 8i. You're always welcome to do this. Nothing against that. I can divide 4a and 8 by 4, which gives me 1 plus or minus 2i all over 2. I know I want to split this into the real and the lateral aspect, which brings me to x equals 1/2 plus or minus 2/2 I, which is really just saying x equals 1/2 plus or minus I. So now this one hits 1 on the right and then 1 forward on the lateral axis. And I guess the other one would be 1/2 and 1 backward on the lateral axis. Perfect. So let's take a look at this one. Last one. Pause the video, try this last one, resume it when you're done, we'll see how you did. Okay, let's take a look. Okay, plug it into our formula. My B is 2. My A is 5. My C is 10. Four. See, 4 times 5 is 20. Times 10 is 200. I know that is -196. Now the square root of 196 is 14, which means that is -2 plus or minus. In this case, square root of 196 is 14 because it's negative. It's going to be 14i. I can divide the 3 of these by 2. And then I'm going to split it into a real, 1/5, and a lateral, which is 7/5 I. So I now go left on the x-axis by 1/5, and I go forward on the lateral axis by 7/5, and I go back on the lateral axis by 7/5, and I have my 2 roots. And there we go.